Welcome to aminacademy.com. Let us see inverse trigonometric complex functions proving tan inverse z and cot inverse z. We know that. Now let z equal tan w, which is further equal where z and w are complex, sin w over cos w. Further, sin w divided by cos w in terms of e power you can write as 1 over I, because sin w we have e power iw minus e power minus iw by 2i, and cos w equal to e power iw plus e power minus iw by 2. By dividing both, we have 1 over I e power iw minus e power minus iw over e power iw plus e power minus iw. Now multiply throughout numerator and denominator by I. That is, we have that means cross multiply by I means, which means we can cross multiply this I here, that is zi equal e power 2iw minus 1 over e power 2iw plus 1. From this, by cross multiplying and get e power iw equal iw equal to iz plus 1 over 1 minus iz. Now here multiply numerator and denominator by I, we get is e power iw equal iz, so I minus z. That means multiply here I, here I means I square is minus 1 minus z plus I, that is I minus z over I plus z. So we have relation now e power 2, from this e power 2iw equal here e power 2w, sorry, not iw, e power 2w e power 2iw, we have what will we express e power 2iw equal to I minus z over I plus z. Therefore, from this, taking length both sides, you can get w equal 1 over 2i ln I minus z, I plus z. Now already we have w equal to, we get first z equal to tan w, therefore w equal to tan inverse z. Therefore tan inverse z equal 1 over 2i ln I minus z by I plus z. Since complex logarithm is multivalued function, it follows that the arc tangent, that is tan inverse x, tan inverse z function is also a multivalued function. We can define the principal value of the tan inverse z function denoted with a capital A by employing the principal values. Therefore, you can say simply arc tan z equals, you can write 1 by 2i ln I minus z by I plus z also can write. This is a arc tan, which means further you can write this as 1 over 2i ln I minus z I plus z plus I arc 1 minus, in terms of x also can write this is a, x is a normal function, x over I plus x. Now this is a tan inverse z function expansion. Now similarly you can say tan inverse, suppose similarly you can say little about tan here, z equal cot w, which is equal cot w equal cos w over sin w, which is equal, we are putting the values, we have I into e power iw plus e power minus iw over e power iw minus e power, power minus iw. Further, here e power iw plus e power minus iw is 1 over e power iw. Here also 1 over e power iw. By simplification, we'll get I into e power 2 iw plus 1 e power 2 iw minus 1. Therefore, from this, we can say cot inverse z equal 1 over, no, before that, here I into e power 2 iw plus 1 over e power 2 iw minus 1. From this we can write cot inverse, same before, cot inverse z equal 1 over 2i. That means you are multiply and divide by I, which gives and simplify, we get 1 over 2i, 1 over 2i ln That means you are taking len both sides, you get that. That is e power to I len z plus I minus z minus I. This is for cot inverse z. That means previously explained about how to get this. Similarly, we are getting cot inverse z is 1 over 2i len z plus I into over z minus I. Now, by giving both values, that is tan inverse z plus cot inverse z, will get pi by 2 plus pi n. Also we can prove where n equal 0 plus or minus 1 plus or minus 2 like it goes. So this also useful result. We have done. Please subscribe our YouTube channel.